Alright, hello and welcome back to the rational root theorem. My apologies, this worksheet, the rational root theorem mixed, was supposed to be the third worksheet, and I put it in as second. As my fault, I apologize for that. There's a step in here that we hadn't talked about yet, and I need to go over that for you. I'm going to look at number 5, and I've already got the notes on this. So my P over Q list is plus or minus 1, plus or minus 3, plus or minus 7, and plus or minus 21. If I go through and try positive 1, get this written out here, and I may erase some of this as I go, which is not ideal, but I don't have a lot of room on this sheet. Bring down the 1. 1 times 1 is 1. 5 1 is 6. 1 and 6 is 6. Negative 31 plus 6 is negative 25. 1 times negative 25 is negative 25. That is obviously not going to leave me a 0. Go on to the next one, negative 1. And rewrite this. 1, 5, negative 31, 21. Bring down the 1. Negative 1 times 1 is negative 1. 5 minus 1 is 4. Negative 1 times 4 is negative 4. Negative 31 plus negative 4 is negative 35. Negative 1 times negative 35 is 35. I think I did something wrong on that one, but it does not give you 0 as a remainder anyway. I'm going to go up here and do 3. It's plus 3. I have 1, 5, negative 31, 21. Bring down the 1. 3 times 1 is 3. 5 plus 3 is 8. 3 times 8 is 24. Negative 31 plus 24 is negative 7. Positive 3 times negative 7 is negative 21. That does give me a 0, and that is one of my roots. So at this point, I would try positive 3 again, and 1, 8, negative 7. Remember, we are going to use whatever the result is, and that just shortens how much work we have to do, which we all appreciate, right? So I have 1, 8, negative 7. Bring down the 1. 3 times 1 is 3. 8 plus 3 is 11. 3 times 11 is 33, and I think we see that's not going to give us a 0 remainder. I've worked through the rest of this with positive 7, negative 7, and I stopped at that point. And when you've worked a couple more and you are not getting another root by synthetic division, then what you may want to do is get this set up in standard form. So I'm taking the 1, the 8, and the negative 7. I'm rewriting that here as a trinomial. And now I have a 1 as my A, 8 as my B, and negative 7 as my C. So now I can use the quadratic formula. All of that over 2a. And now when you plug in the 1 for the A, the 8 in the place for B, and negative 7 for C, and you work this out, I'm just going to go ahead and give you the answer that I worked out earlier. Negative 4 plus or minus the square root of 23. So I have x equals positive 3, and x equals negative 4 plus root 23, and negative 4 minus root 23. So those are my two answers. And I'm done. How do you know when to quit doing synthetic division and when to go on to the quadratic formula? Really, if you get this down to 3 terms, you can go ahead and do it. For me, I go ahead and do at least 1 or 2 more and see if I can find one. And then if I only have 3 terms left, I will go ahead and do the quadratic formula. If you have more than 3 terms left, synthetic division will help get it down to 3 terms so you can use the quadratic formula. Anyway, I hope that clears up some of the frustration from yesterday. Again, I apologize. This was supposed to be the next worksheet, but hopefully, again, this will help. Good luck. Continue working on the same problems. I'm going to add probably 2 more problems just to make sure that you got plenty of practice. You're good to go with this. And then we're going to switch it up for tomorrow. Do something a little bit different. Attack this from a different angle. Have a great day. Bye.